Okay, I am going to go over this fake quiz with you, and you will not have time in class to ask me any questions about it because we're trying to use our time wisely. So if by any chance you don't understand something that I've gone over, then I need for you to come in during in period or before school if you just let me know. Okay, so let's just take a look at question number 1. Tell whether the graph is growth or decay. Okay, so the number that you want to hone in on is the base. If the base is bigger than 1, then it is growth. So for part B, the base is less than 1, so it's decay. Number 2, this is where you're just going to simply write a function. You're not going to solve anything. You do need to know what the word depreciate means. It means go down. And so we're going to start with our template. And that template looks a little odd right now, but it'll come together here in a second. Had to provide some space here. So this value of A right here is the initial amount. That's 12,000. Since it is depreciating, we're going to remove the plus and just put minus. That rate is 12%. So I'm going to put 0.12. I can subtract this amount now. Don't leave it like that. That's like 100 minus 12 or 88, which is 0.88, and you're finished with that one. That's all you need to do. Okay, the third question you're going to graph, and this seems to be the one that most people have problems with. So start with graphing the function. I'm just going to be honest with you. I used y equals mx plus b, my little shortcut. I'm going to begin here at -2 because the y-intercept is -2 and the slope is 2. So I'm going to rise 2, run 1. I'm going to create that line. Now, if you can't do it that way, use your table of values and just choose your x values. You can choose any of these values right here and just substitute them into this equation. All right, so I'm going to draw the line. Now I'm going to write the graph in its inverse. So I'm going to start with the original function, and I'm going to rewrite that f of x into a y. Inverse is all about switching the x with the y, so you'll notice that I just swap those out, and now I'm going to solve for this new y. So I'm going to add 2 to both sides and divide by 2. And what I can do, let me back that up. You have to divide everything by 2. But keep in mind that most equations are not going to be written like this. So we're going to split this up into 2 separate entities because 2 divided by 2 is 1. And this is nothing more than 1x over 2, or 1/2 x is the same thing. And so this is my inverse function. We're going to put the label back on it, and that will be our answer. Now to find the inverse of this, the easiest thing to do would be to come over here and switch the ordered pairs around. So instead of 4, 6, I'll graph 6, 4. And instead of 2, 2, I'll graph 2, 2. And instead of 0, -2, I'll do -2, 0. So that's simply how you graph it. It's not difficult. All right. So question number 4 and 5, rewrite these in their inverse form. The first one is write it in logarithmic form. So you're going to sink the base. The base is always the base. The log always equals the exponent. So it's log base 4 of 64 equals 3. Remember, your check is 4 cubed equals 6. The next one is starting with a logarithm and rewriting it as an exponential. So as you can see, you have 4 squared equals 16. Okay, number 6, express as a single logarithm. All right, so when you're subtracting logarithms, you're going to actually divide. So I'm going to get 9 divided by 3, which is 3. And notice it says simplify if possible. So the question is, what exponent can I put on 3 that equals 3? And the answer is 1. Number 7, again, since it's subtraction, I'm going to rewrite this as a division problem. I can simplify that to 8. And I can simplify again because what exponent can I put on 2 that reaches 8? And the answer is 3. Now number 8 goes back to the concept that we learned about inverses. When you have a log base of 4 and an exponent with a base of 4, then they're inverses of each other. They kind of undo each other. So you can just strike those out, and really all that's left is the 6. And that's how those inverses work. Number 9 is using the change of base formula, so you need to know that. It's going to be the log of 20 divided by the log of 3. You just simply take that 20 and put it here, and take that 3 and put it here. And it's very careful. It's very important that you put this into your calculator properly. So what I would do is I would put in the log of 20 and hit enter, and then hit divided by the log of 3 and hit enter. And that way you don't have to worry so much about the parentheses. This is what you should get, so make sure you practice that and that you get it. Okay, the next question is very similar to question number 3, only I'm giving you the x values and you have to solve for the y values. So here is our function. When I put in all these numbers, I'm going to get different output values. So here they are. I'm going to graph those, and it is exponential. To find the inverse, I'm just going to simply switch my ordered pairs. You'll see how I just switched each ordered pair, and I'm going to graph those, and that answers that question. So again, if you have any questions over any of these problems, you need to come see me before class on Wednesday.